Okay, so let's say your math teacher gives you a worksheet that looks something like this, and you're supposed to be finding missing sides or maybe missing angles, it could be, of right triangles. One of the biggest questions that math teachers get is, how do I know whether to use sine or cosine or tangent? How do I know what to use? So let's talk about that. The first one I think I want to do here is number 5 on this sheet we were just looking at. There it is. So I'm going to draw number 5 myself. And let's see, I have 8 and 20 degrees and x. Okay, so here's what that problem looks like. And the first thing we have to do is decide which side is the opposite side from angle 20 degrees, the angle marked 20 degrees. Which side is the opposite from that angle? Which side is the adjacent to that angle? Which side is the hypotenuse? Now, if you're not good at doing that, that's going to hold you back. So you have to get better at doing that before any of the rest of this is going to work for you. Because if you misidentify, if you call this side the adjacent, for instance, it will make the entire problem wrong. Okay? So I have another video I will link here in case you need to look at that first, how to decide whether it's opposite or hypotenuse or adjacent. But in this one, we're going to go look at everything from the perspective of the 20-degree angle. And that has two sides. And one of them is a hypotenuse. It will always be, one of the sides of your angle will be the hypotenuse. The other one will always be the adjacent. And that makes this one over here the opposite. So now I know that the two sides I'm working with are the opposite and the adjacent. There's nothing happening over here. It wasn't given to me as something to use. It's not something I'm trying to find. The ones that I'm working with are opposite and adjacent. Okay, so once I establish that, I'm going to look at my definitions of the sine, the cosine, and the tangent and figure out which one uses opposite and adjacent. And the answer is tangent. So that's how I know what to use here. So I'm going to say the tangent of 20 degrees equals the opposite side over the adjacent side. And I can put this over 1 and cross multiply. X times tan 20 has to equal 1 times 8. All right, is x by itself? The answer is no. X has not been isolated yet. We haven't solved for x yet, so I won't pick up my calculator yet. I will instead keep going to get x by itself. This is times, x times tan 20. So to get rid of it, I divide. These will cancel. And now x is alone. Now it's time to pick up the calculator because now my equation tells me what to put in to get x. So I'm going to put in 8 divided by tan 20. And my answer is 21.979. I'm going to call that, really, if I round that to the nearest tenth, I'm actually at 22.0. So let's go to the tenth and say that's about 22.0. And that is this bottom leg here, the length of the bottom leg. All right, now let's look at one of the other problems. We just did number 5, and now looking up above there, I wanted to point out to you that on 2 and 3 here, you notice that it doesn't just give you something for two sides. So let's look at number 3. In our last problem, there were only two sides that had something written on them. One of them didn't have anything written on it at all. So I knew which two sides to use, but this one's not like this. There's something written on all 3 of these sides. So how do I know what to find first? How do I know if I find C first or D first? And how to set that up? Well, here's the thing. Basically, it's your choice. You get to decide whether you would like to start by finding C or start by finding D. We're not going to work with both of those at the same time because we don't know both of them. And we don't want to have an equation with 2 unknowns. We want our equation to have just 1. So I'm either going to work with the C and the 7 or the D and the 7. I'm going to go ahead and start with C personally, just because of alphabetical order. No good reason. You could just as easily start with D. So to start with C, I basically ignore the D. And I say, okay, what have we got here? Here's my angle. It has 2 sides. One of them is the hypotenuse. The other one is the adjacent. So this is the opposite. So if I'm trying to find C, I'm working with the opposite side and the hypotenuse. So I need to figure out which trig function uses opposite and hypotenuse. And that's sine. So that's how I know to use sine. All right. So I will set up an equation for c and 7 with sine. So sine of 42 degrees equals opposite over hypotenuse. I'm going to put that over 1. I'm going to cross multiply. 7 times sine 42 equals c. Is my variable alone? Yes, in this case. So I don't have to keep going. Once my variable is alone, once it's isolated, I'm ready to put it in the calculator. Whatever it says is going to be equal to c. And it says 7 times sine 42. So c is approximately equal to 4.68. Let's go with 4.7. So that's c. Now in this problem, though, we weren't just asked for c. We also are supposed to be finding d. And I'm going to say approximately. There's a couple of options on how we could do that now. Because now I do know 2 sides out of 3 of the triangle. And if you know 2 sides out of 3, you can use the Pythagorean theorem. So I could do that. I could say 4.7 squared plus d squared equals the hypotenuse squared, which is 7 squared. That's one option. I personally prefer not to use something, in this case the c, that I just rounded to find something else. Because if you are basing your answers on things that have already been rounded, you're just constantly getting farther and farther away from the most accurate answer. I would rather use just the 7 and the d. So I'm going to set up a new trig equation. So we already said that for the 42, this is the adjacent, this is the hypotenuse. So it's like this time, I'm pretty much just ignoring that. So I'm just going to write an equation that relates the d and the 7 to the 42 degrees. So adjacent and hypotenuse, that's cosine. So I'm going to write an equation that says, and let's go ahead and I should have moved this over because I want to write it side by side, but I didn't. So sorry, it's a little offset. Cosine of 42 degrees equals the adjacent over the hypotenuse, d over 7. So now I cross multiply. 7 times cosine 42 equals d. D is alone, so it's time to put it in the calculator. And I get about 5.2 for d. You probably would have gotten the same thing if you used the Pythagorean theorem. It's not a huge difference to try and be a little bit more accurate. I just prefer not to base the next step in a problem on something that has already been rounded, which means it's an approximate answer, if I can base it on something that's exactly what the value is. All right, and there you have it. Okay, so if you have to find 2 missing sides, you basically just have to pick one to start with. You can't do them both at the same time. Okay, so let's finish this off just looking at a few more how do I know examples. Okay, so looking at this first one up here, how do I know what to use? Well, the angle has 2 sides. One of them is the hypotenuse. One of them is the adjacent side. That makes this the opposite side. I'm not working with anything over here at all. I'm working with the opposite and the adjacent. Opposite and adjacent, that's tangent. So that's how I know that I'm going to set up an equation for the tangent. So tan 32 degrees equals opposite over adjacent 10 over x. Okay, and we'll come back to that, but let's just set them up at this point. Next one, right here. If I'm trying to find m, and I have the 12 and I have the 26 degrees. 2 sides to my 26 degree angle, one of them is the hypotenuse. In this case, that's the m. That makes this the adjacent. Here's the opposite. So I'm not working with opposite. I'm working with the adjacent and with the hypotenuse. Adjacent and hypotenuse. That's cosine. So I'm going to say cosine of 26 degrees equals adjacent over hypotenuse. That's how I know to use cosine there. All right, and last but not least, throwing you a curveball here. Here are the 2 sides of my angle. I don't know the angle. What the heck is that? That is the Greek letter theta, or my representation of it. Theta is a Greek letter, as I just said, that we very often use as a variable when we're talking about angle measures. So this is just like if it said x. So this is my angle. Here's the hypotenuse. Here's the adjacent side. And here's the opposite. So it looks like I'm working with opposite and adjacent again. So again, I'm going to use tangent. So tangent of my angle, which we don't know, but I have something that stands for it, equals opposite over adjacent. Now I threw that one in there because I wanted to point out that even if you haven't gotten to the point where you're finding missing angle values yet, it still gets set up the same way. We still use the same things. We figure out which is hypotenuse, which is opposite, which is adjacent, and then we still use that to figure out which one of these are we going to write an equation for. Which equation are we going to use, basically? Which equation are we going to fill in? And in this case, it's tangent, okay? So you may not know what to do next there, but you still can set it up. Let's go ahead on these two and finish the problem. All right. If you haven't finished that one, go ahead and try to see if you can get it done. Pause the video and then come back. All right, so that would be cross multiplying. I get x times tan of 32 equals 10 times 1. Is x alone? No, it is not. So I have to divide the tan 32 out so that x will be alone. Once x is alone, whatever's on the other side tells me what to put in the calculator. So 10 divided by tan 32. And notice that what I'm doing here answers the other common question, how do I know whether I'm going to multiply or divide to get my answer? You know because you don't just guess, you do the equation. You write an equation, and then you go through the steps to solve the equation, and when the equation is solved, it tells you what to do. It tells you whether you're going to divide, or in case of some of the ones we did earlier, multiply. Like here, told me to multiply. All right, here's another one. Let's go ahead and solve it. If you haven't already, you might want to pause the video, try it yourself, and come back. Okay, here we are. We're going to go ahead and cross multiply. I get m times cosine 26. I'm going to bump into this other problem very soon, so let me do that. Equals 12 times 1. Is m alone? No. So I have to divide out the cosine 26 so it will be alone. And now m is alone. And what happens on the other side is telling me what to do. To get m, I want to divide 12 by cosine of 26. And I get 13.35 or about 13.4. Okay, so just in case you have already learned how to do angles, or if you just want to see a preview, let's go ahead and do this one. We set it up. We knew it was going to be the tan. And now we're ready to solve. Here's the thing. We're not going to cross multiply. Because if we did cross multiply, we still wouldn't know what to do because we kind of have to get this tan away from this angle. We want our final answer to just say the angle is however many degrees. So here's how that works. When you have to solve for an angle, a missing angle, and this is the only time you do this when you're finding a missing angle, to undo the tangent, and like I said, you can't divide by tan here. Tan doesn't have any meaning by itself. Tangent of an angle means something, but tan is not like a number I can divide both sides by. So when you have tan of an angle, sine of an angle, cosine of an angle, and you need to try and get the tan part away from the angle or the sine part away from the angle, you have to do inverse tan. Inverse tan is like undoing tan. So if I have inverse tan and tan, they cancel each other out. So you do that to both sides, and what that gives you is on the other side, and that's how we read that. It's not really tan to the negative 1 power, it's inverse tan. It's a notation thing. Inverse tan of 5/7. This is like working backwards. The inverse is like working backwards. It's like they said, hey, I took the tan of my angle and I got 5/7. You tell me which angle I took the tan of. So you're working backwards to find out what angle has a tangent value of 5/7. And that's inverse tan. Is going to help me work backwards. So I do second and tan, because right above the tan is a little inverse tan. Second tan, and then I can put my fraction in. I could also just put it in as division. In other words, I could type it in like this, which I personally very often do because I grew up without a fraction button. And that gives me about 35.53, about 36 degrees if I round it up to the nearest whole degree. And there is my answer. Now, if you haven't learned how to do angles yet, you have seen a little bit about how it's going to work, and you're ready for your lesson on that. But don't get wigged out by it because, you know, if it's something new to you, just realize that. So we're all good. Okay, I hope this has helped you, and you can check out my other videos, and always feel free to let me know if there's something you need help with that you want me to make a video for. Thanks so much. See you later.